Well, hello friends, and welcome back to browser hacking. Today we're going to be implementing script source in the web, because currently the only kind of JavaScript we support is inline JavaScript. So like a script tag that has a script text inside of it, but it would be cool if we could refer to an external script. So let's make a little test for that. Let's see, home, non, dub. And why don't we put it in the welcome page? So we'll make a little script here that refers to some other thing. What do we want to put in there? Test.js. Just that, and then this thing should load. So we'll just put something simple in here, like it loaded. And I guess we can verify that this works in Firefox. But yeah, so it loaded right. The trick to all of this is that we have to run that script before we continue parsing the document, because that's my understanding is that that's how everything is required to work. That basically the world that is visible to this script. So if we were to do like document.getElement by id meep, then if meep were here, then it should be visible in the script. But if meep were below the script tag, then this would fail, because this script will run immediately synchronously and not later on. So I think you can run scripts later on by doing like async or something like that, right? But it's the most common way you see scripts run is this way. So we should add support for async as well, which is actually a lot easier because we can just run the script whenever the load finishes. But we'll start with this. So actually, I guess we can check that this fails. So we'll put a little meep element after. Oh, just like we have it right now, actually. We'll put it down here. So this should say it loaded and then null. Yeah. So currently what happens if we try to run this in our browser is that probably nothing will happen, because the way that we handle script tags is that, let's go look in script element. So when a script element is inserted into, in this case, it's inserted into its parent node, but basically when it becomes part of a document, then what we do is we traverse all of the children of the script element, and for all the text children, we just concatenate the contents, and then that becomes the source for the JavaScript. But I think here we're going to have to differentiate. If there's a source attribute, then we need to load a script instead of taking the text inside of the script tag. There's probably some nuance to this that I'm not aware of, and that's the kind of thing that we can pick up later in life. But right now, let's just let's see. So let's say auto attribute source is attribute. Maybe we'll do something like this: attribute source. Wait, does string have a Boolean operator? No, it doesn't. Okay. So if source is not null, otherwise we will do the script from, let's see, wait, let's do it this way, string source. Okay, so if we have a source attribute, then we will try to load, and then source is going to be, how do we do this? So we don't have any way to load synchronously right now. Like all the loading mechanism is completely event loop driven. So you schedule a load. Let's see how we do that. So we'd say like resource loader, the load, and I forget what the API is. Load a URL and a success callback and an error callback. So let's just take a look at somebody who's doing this. I guess the error callback can be absent. Okay. I guess that's fine, although maybe we should probably raise some DOM event or something, or I don't remember exactly what a script element does when it fails to load, but we can look into that later. So this part actually from load image is kind of similar to what we want to do here. So we definitely want to complete the URL, because URL completion is all about relative URLs. So we probably, in our case, we know we have test.js, which is a relative URL. So if this were an HTTP request, we would have to, or actually for any kind of URL, it doesn't matter what the protocol is, we have to compute the URL based on the base URL of the current document. So that's why we have to ask the document, hey, can you take this relative URL and turn it into a completed URL? So we do that, and then we call resource loader load. So I'm thinking maybe we should have a load sync. There are more sophisticated ways to do this, because the way that we're doing that, if we do this with a synchronous call, that means that we will block this thread essentially until we get a response. And perhaps a more sophisticated solution would be something like having a pausable parser, that you could pause the parser and schedule the load, and then when we get the response, then we can unpause the parser and resume. But right now, let's just go for a simple approach so that we can move forward. So I think maybe we'll have a load sync, and that means that we need the source URL, but we don't need to make a weak pointer to this thing, because we're going to be called, the callback is going to come in right away, essentially. So data is null. So if we don't get data, I guess we can say HTML script element. Actually, since we are doing a synchronous thingy, we can even capture by reference, because it doesn't matter. Okay, and then here what we need to do is just say script or source is string copy of data. Okay. And in our failure, let's see, so if this fails here, if source is null, which means that we never set source, either because we had an error or because the response was empty. So if source is null, we'll just debug HTML script element no source to parse, return. Okay. So this seems vaguely sound. Let's go and actually invent the load sync function on resource loader. So currently there's only load. We'll add load sync. Okay, so what is the easiest way to implement this? I think maybe it will be to make a nested event loop. I think. Or, I'm not sure actually. we'll try it. So let's see. If we wanted to make a new event loop, then we would just make one right here. Event loop. We'll call it loop. Make core event loop. And now we're in a new loop, right? Because this will just push a new loop on the loop stack, I think. Doesn't it? Loop stack, wait, who pushes them on the loop stack? If there's no main event loop, then this becomes the event loop. Event loop pusher, okay, so who makes an event loop pusher? Okay, when we exec the event loop. Okay. So we gotta do loop. We can actually do it this way. So this will be our nested event loop, and in here we can just fire our load request. So load URL move the success callback and move the error callback. And then it will execute in the inner event loop, and then when we get back here, we won't get back until we got our response. Yeah. I think that'll sort of work for now. It's not the most glorious, beautiful solution, but I feel like it can take us where we want to go. At least until we make a more sophisticated possible parser. Suppose we could do the event loop stuff here, but I feel like this is a better abstraction. Alright, well that didn't work out. Maybe we should... I guess we can take a look at the DOM. We don't have DOM. Do we have anything to look at? Oh, a crash when trying to display the DOM tree. Wonder why that is. Dump tree called with a null pointer. Oh. So, oh, you can actually see here where we are. So we are in load sync. So we're in the nested event loop inside load sync. Oh, because we never bail out of that loop, of course. Of course. I'm stupid. Of course we have to do something, otherwise we're going to stay in that loop forever. So we need to set up our own little callback here. So we'll make a new callback. It will be success callback. We're going to take this with us. And we're also going to take the error callback with us. And then in here, oh wait, how the hell do we do this? Oh, actually, we can leave them on the stack. That's fine, because we're staying here. Okay, so it doesn't have to be so complicated. So in the success callback, which will be the first one, all that we need to do is take a byte buffer. So success, then we get some data. What we do then is we just invoke the success callback data, and we will immediately exit this event loop. Yeah, so we'll exit that one. Quit. That's how we do this, right? How do we do, I just have to look at how other event loops work. So for dialogues, we have dialog exec, which creates a new event loop, and then executes it, and then dialog done calls quit on the event loop. All right, so we got to do the same thing, sort of, that we call quit. And in our error callback. So yeah, okay, now I get it. So we do the same thing one more time. This is our, wait, why does this look so crappy? Okay, that's better. And the error callback, and we have a string. What is that even? Is it the error message, I guess? I don't remember what it was. Message. I call it string. Okay, so whatever happens, we will quit the loop. If this works, then this is kind of a nice way to express what we're doing. Although I would like it, it is a bit verbose. Like I would like it if you could only specify that they should exit the loop once, but I guess you could have a third callback that would be like, whatever happens, always invoke this callback. It loaded, but it's an element. Okay, so it loaded, but it seems like we could see the element when it loaded. So it may have ran way later. How the heck did that happen? So let's figure that out by let's see. We'll figure that out by doing backtrace here. So we'll say running script. Or let's actually only do this for the loaded script here. So source is string that, so got source. So the fact that we could actually see the element and something was coming in the alert box means that we were not supposed to see that element. So it means that our script is probably executing at a later stage. And I'm not quite sure why that would happen, but here we have a backtrace of when the source was acquired. So let's see what that looks like. So we are in parse document, parse, and then we are in load sync, which creates a new event loop, and then sends out the load request. And we get a callback. We got source. But that part is so weird. Like, why is it seeing that thing? I gotta look at that again. It is null. Okay, so the way we set it up is that this is test.js, and it looks for the meep thing, right? Yeah, get element by ID meep. And meep is here. So this should fail. Why doesn't it fail? That's so weird. I'm so weirded. So let's simplify this a little bit. So we'll get rid of this script right here. And now we have only one script. And that means that we can also maybe like print something right here when we run the script. Running JS. All right, so we'll get our backtrace there. Oh, wait. I think I know what this is. We're running it at the right time. It's just that when we are these insertion callbacks, like inserted into, they are the very last thing that happen in document parsing. So when we fire these callbacks, I'll show you in the parser, it's like the very last stage. So parse HTML document, it will create a new document, set it up with some URL and source, and then call the parser, and then it does a little bit of fix-up to repair some DOM brokenness, and this needs a lot of work actually. And then the very last thing we do is, well, the very last thing we do is send in DOM content loaded event, but right before that we fire the insertion callback, which will recurse through the entire document and call inserted into on every node that has a parent. And this is the thing that triggers our script. So this is tricky. This means that it's not quite good enough. Like we have to do this sooner. So one option is, so what are the options here? I guess when we encounter the script element and we parse the source attribute, then we could do it at that point. But I think that's too soon. I think inserted into is fine, but maybe the thing is that we have to insert these things. Oh, how should this work? Because by the time we get here, we already have a full DOM, and that's the problem. We're not supposed to see the full DOM when we're running that script. So we have to, either we can do inserted into when we create each thing, but then it's not going to have its children yet, and the fact that it has children is what allows us to accumulate text nodes that are children of a script element, for example, which is how the inline script works, and inline style sheets and stuff like that. So it is tempting to go and look at how other engines do this, but I would rather not. So I guess we can... Okay, what's something that would solve the immediate situation? I guess it would be if we fired this sooner. That would work. Or another option would be that we actually waited with inserting until we got to this point. So we would sort of build a temporary DOM tree, and then we would assemble it here. I'm just thinking, then you would want to know when you're inserting something, and then also after you've inserted all of its children. So I guess those are two kind of different things. Like, you've inserted the DOM node in the document, and the DOM node's children have somehow changed. And it's when the children change, that's when you want to accumulate the text and the children for an inline script. Okay, so to get out of this right now, I don't know which one I like, which approach I like. That's so annoying. Let's just pick one and go with it. Just pick one and go with it. Just pick one. Just do it sooner. Yeah, okay. So we do it sooner. That means that while we're parsing, and we do an insertion. So when do we do that? We have node stack append, commit, open tag, commit, blah, 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 close tag, close tag. So open tag. Append child. Yeah, so when we open a new tag, that means that we are appending it to its parent. So we could do the insertion callback at this point right here. And this will be a little awkward, but I think this might be okay for now. And then we'll just have to make the text accumulation in inline scripts and inline style sheets work a little bit differently. So append child, I think actually that's what the false here is. The false means that it won't call inserted into. Append child. Right, call inserted into. So what if we don't tell him that? We just say append child. And maybe the same thing with these guys. And we'll call inserted into immediately. All right, and then then we don't need to do this afterwards, so we'll just comment this out. And I think this will break regular scripts and regular style sheets, but I think we can fix that. We just need to notify parents when their children change, and then we can react to that. Okay. It loaded. No, that's good. And then this went vaguely okay, but some things did not work out. So what went wrong here? Let's look at the DOM. So now I guess we got some inserted into callbacks at some unusual times. So we have some text here. Oh, this is probably the style sheet actually. Yeah, the style sheet is not, we have no styles. Oh, never mind. I think that's it. The style sheet did not load. If we dump the, wait, how do you do that? Dump style sheets. We can see that there are 0 rules. So yeah, so we have to have something for that. So let me show you what the style element currently does. Yeah. style element. So style element will react to inserted into, but now will get called, inserted into will be called when the style element itself is inserted into its parent during parsing, which means that that happens before the text inside the style element has been parsed. And I think that's probably okay. So what we'll do instead is when the children change. Children did change. Something like that. Children changed. Okay. Yeah. Children changed. Let's try this, how it works. Okay, so then in children changed. So that will be like whenever we're doing an append, wait, is inserted into, is that here somewhere? Append child, okay. So when you call append child on somebody, we will finish this by doing static cast d this children changed. Let me see how this is defined. Okay, so we probably have to declare this guy here as well. It's okay. Just because DOM nodes and layout nodes have a shared base class called tree node. So whatever we add for the DOM, we have to also make sure that there's a dummy for the layout tree in case we don't need it. Anyway, so when we append a child, we'll say your children changed. When we prepend a child, we'll say your children changed. And when we remove child, I guess then we will also say your children changed. That makes sense? So let's see. So now style element will react to the children changing, but nothing else. HTML style element. Right, so we need to call to a different base class thingy. Children changed. This kind of makes sense because if you're like manipulating the children of style elements or a script, like if you're one of those weird people who do something like I don't know, like setting inner HTML on style sheet node to change the style sheet. I don't know if you can even do that. There's all kinds of weird stuff that you can do and that websites actually do in that general area. So it's probably good to handle that scenario. So let's see if this makes us load the style correctly. It loaded, no, and we got the style. That's pretty cool. But our canvas demo does not work. Why is that? I guess because it uses an inline script. So the script element, now we have to take care of these a little bit differently, because in the case of a script element with a source attribute, we don't have to wait for text inside of the element, we can just start loading right away. But when it comes to script that has text inside it, we gotta do this. So we'll have to override that guy. Okay, I feel like this doesn't feel exactly right the way that we're doing this, but I think maybe it's okay. Children changed. And yeah, so we'll just accumulate child text like that. And I guess if there is a program to run, if source is empty, return. Okay, and then here, if source is null, we can just return. And we'll put the, we'll do it this way. String source. Yeah, okay. So now we have separated the handling of script element with text inside them and script elements with no text. What should happen if you have a source attribute and text inside? I feel like if you have that, if you have both, then we should not care about the text inside. I'm not sure if that's correct, but I think maybe we'll do it that way. Wait, maybe there's a nicer way to say this, more expressive. If has attribute source, return. Yeah, that's a bit nicer. I don't know what the right behavior is. Maybe you know. I mean, we could test it, I guess, with another browser, but it's fun to build without cheating and see what you come up with, and then you can compare it later against how other people do it, and then fix everything, of course. Okay, so now we died. Why did we die? So we are in alert. So doing an alert, and then we do an event loop in there. And in that event loop, we get a callback. Wait, what? We do an alert. Script element inserted into. Wait. Okay, so we are inserted. So I guess we do the source thingy. Oh, yeah. So we're alerting inside of the script. And then we get a load sync callback inside the script, but why are we getting that callback so much later? We already got them. That's very strange. So script element inserted, then run the script, then call alert, then show a message box, which creates a dialog, which creates a nested event loop. And in that nested event loop, we fire the first callback. This should be an amp, by the way. Okay, so let's say here that we will enter load synchronistic loop. I just want to see what these what they look like. If we actually leave the nested loop correctly. Because if we fire either of these callbacks, then the other one should never fire. That would be a bug. Okay, so we exit the nested event loop here, enter load sync loop, got source. All right, that's good. And then we exit the thing, and then we run the script. And then we enter a new loop. Why is there such a callback waiting for us? What can we do? I guess we can do something like string format. Can we do something like this? I wonder. That would be kind of nice. Am I even allowed to do this? I'm not. All right, all right. Okay, well that was a very strange way of doing that, but I'm hoping to be able to see if we actually get these callbacks an extra time for some reason. Because I'm a little bit confused about what actually happens here. Okay. So we got the success callback here. Exit the loop. Wait, so we got the success callback here, and then we're getting it again later. Well, that's certainly not right. We should only get the success callback once. So why are we getting it twice? What happens when we do loop quit? It will just, when we go back to the loop, to the event loop, then it will know that we have requested it to quit. Then when we exit here, but why are there two success callbacks? Are we calling inserted into twice, maybe? Let's verify that we don't do that. So, script inserted into new parent. new parent. All right, just something like that. I just want to see if this is happening more than once, because maybe I'm misunderstanding what I'm looking at here. This is turning a little trickier than I was expecting, but that's good. It's good to get a little reality check. So here is our insertion. Here's our first success callback. There's no second insertion, but we get a second success callback, so that's definitely wrong. Why do we have that callback? So let's see who makes that callback. We call load sync, which we'll call load. And then what does load do with the success callback? Presumably it's a file URL, so it will do a deferred invoke with the success callback. So a deferred invoke will post a deferred invocation event on the event loop queue. Okay, so post event. I'm thinking maybe we are, So the thing is, when you exit a nested event loop, then you might have, the nested event loop might have some pending events that didn't get handled yet. So say that you have you do like a click on something, and that click event handler tells the event loop, all right, just stop handling events and unnest, right? The event loop at that point might not continue with the remaining pending events, but instead it will just take all the pending events and sort of give those to the outer event loop, like the outer from the next level up or whatever, and just have him inherit those pending events. And then the outer event loop will receive those events and be able to react to them. And I think maybe what's happening here is that we have that deferred invocation, and then when we exit the nested event loop, then the outer event loop inherits the deferred invocation event, so that the deferred invocation happens twice, because it happens once in the nested loop and then once afterwards when it's been inherited. So this is when the exit has been requested. So this is this is event loop pump, which pumps the event loop, handles events. And this is where we end up if you call event loop quit, which we are doing. So an exit from this loop has been requested, at which point we want to create a new event queue, which is let's see, so we set the capacity of the new queue to be all of the queued events we have plus events.size. What's events? Okay, so m queued events at this point. At the start of event loop pump, we take whatever's in m queued events and move that to a local. This is because calling event loop handlers may actually queue up more events, and they will then end up in m queued events. So this here is to make sure that we don't lose anything any events that were posted by recent event handling here. We actually have to copy any new events together with the events that we're in the process of handling. And then here we loop from the current I to the end of the vector that we're currently handling. I think maybe this is the bug actually. So because I is here, so we are looping over the copy, or we took and all the pending events, put them in a local, and then we're iterating over that local vector here. And I is our iterator, so at this point, the handled event, the event we just handled is I. But down here, we actually take the event we already handled and put it in the new event queue, which is what the outer event loop will inherit from us. So let's see, and the inheritance happens, so this is the exec, which is, this is like the loop that runs the event loop. So it's just an infinite loop until exit is requested, at which point we return, but until then we just do pump, 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 pump. So that's how the event loop works. And the event loop pusher is an RAII object. And you can see here that when we enter into a new event loop context, then we take all the pending events from the previously current loop, and then the new loop becomes the current loop. And when we exit, then we remove ourselves from the event loop stack, meaning that the next outer loop becomes current, and then the new current, so the outer loop, takes all the pending events from the event loop that we're just leaving. I realize that maybe this is confusing, but if you've worked with event loops, then you probably understand what this is about. And otherwise, I like to imagine that this is actually kind of a simple event loop to understand if you want to go look into how it works, because it's not terribly complicated and it's a very, very useful thing to have. Anyway, I think this is the bug here, that we are we're iterating over the queued events and then handling an event, and then we're handing it out to the outer loop to do it one more time. So here we will start this loop by going to the next I. Yeah. That makes sense to me. So I think this probably means that we've had a pretty stupid event loop bug this whole time. In that whatever was the event that caused us to exit the event loop, that event would replay on the outer event loop, so it would fire twice. And I guess the typical way that you would see that is like if you cause a message box to go away, for example, by like clicking the OK button, then the OK button click would fire once more in the outer loop, if that makes sense. Clickety, clackety, everything is good. Fun demo? Totally works. All right. Oh man, okay, so this really went all over the place. But this is very, very good. So just verifying that our, oh, this doesn't have focus. It would be good if the enter key would kill that window. Oh, we dead. What happened here? Script element inserted into load sync. Yeah, but why did we die? Handle mouse down. Wait, what's going on here? Okay, well, there's some stuff to fix, I guess. Let's see if we can reproduce that. Yes, yes, it loaded. Click. Very dead. All right. So this kind of doesn't feel like it has anything to do with what we were just fixing, but I guess we can quickly take a look anyway. In HTML view, mouse down event. So what was that? It was assigning to a ref footer to layout node. Operator equal, or assign operator rather. How did I was touching this earlier today, so probably, okay, I'm not gonna get into this right now. We have so much going on already. But that's definitely a regression. So this fix here, I love it. This is such a good fix. Let's just verify that this guy here totally works. And let's try creating something here like foo. That died. Oh, but I've seen a bug about this. Damn it. Finding so many problems. Might be time to start fixing some bugs in random places. So what is this? Some invalid index. Yeah, okay. Let's test it here then. So we'll change something and then try to quit. Would you like to save? Cancel. Would you like to save? Yes. Oh, I guess I just saved that file. Yeah. So do that. Would you like to save? No. What if we just edit but we don't have a file name? Would you like to save? Yes. Cancel. I'm not sure that interaction ended the way it was supposed to end, usability wise, but because I feel like if I cancel at that point, we should cancel quitting the program. But now we are so far outside of what we were supposed to be doing. So this stuff seems to work. The event loop fix seems sound, so let's add it. Libcore. When leaving a don't replay last handled event when leaving a nested event loop. The event that triggered quitting, that triggered exit from an inner event loop would always get replayed, redelivered, or get redelivered in the outer event loop due to an inconspicuous off by one. Due to a silly off by one error. Oh, it doesn't fit. Mistake when constructing, when transferring pending events between loops. Yes. Very good. Then let's see, do we have any standalone changes here that we can do? I guess we can do the load sync mechanism by itself. So we'll get rid of all this debug nonsense. But man, am I glad that we figured that out, because it's definitely not good that a deferred invocation would fire twice like that, or any event would get handled twice. Definitely not good. Resource loader, CPP. That's actually quite a tidy solution for that problem. It's not the most mature or beautiful, but it's like nice and self-contained. Good enough for now. This function creates a nested event loop and runs a load operation inside it, returning only once the load has either succeeded or failed. This will use to implement blocking loads. Ew. Blocking loads are pretty gross, but what are you gonna do? I mean, there are things we can do and we should do, but we're not gonna do them right now. So what else do we have? So we're changing the way that DOM is notified about insertions. So now insertions happen during construction, because that means that we can load a script and we don't see any more of the DOM than we should by the time the script runs. I think that's correct. Like, we basically we have to run the script at that point. Otherwise, it's like not correct behavior, and it's very observable. I have a feeling that this solution here with the separation of children changed and inserted into it, it feels messy, but I'm not super clear on what a better solution is at the moment, but I'm sure that one will spring up eventually. And I guess since we're doing this, we can actually go in tree node and get rid of that called removed from parameter, because now, or wait, who's using this? This is always true anyway. We can get rid of call inserted into, because I think this is always going to be true now anyway. Simplifies this a little bit. Call simplify the APIs. Very, very nice. And then we can change the code a little bit in this guy. Wait, I'm already editing this somewhere. Where? Here? Alright. I don't want to like throw up an alert immediately when we load this document, but we could do something in there. Like, let's see. Let's check out, oh, HTML parser, line 100. Oh, see this guy right here. Now we'll call insertion too. That's nice. Forgot about that one. So, the HTML. Yeah, forgot what I was doing. So currently we have this inline script here that sets the user agent string here, and this should actually fail now since it's not. Wait, why was it like that? So I guess it worked before because of a bug. So yeah, so I wrote the code this way, but this is clearly wrong because it's trying to find UA, which occurs later on. So I'll show you what that looks like. So if we open this in Firefox, your user agent is not here because, can we get error is, please? It doesn't tell us. I thought that this would give some error or something. Oh, well. All right. Well, anyway, we can't see it at that point. It's too early. So this actually needs to be like document add event listener DOM content loaded. Something like that, right? And that'll make it work. So now get element by ID can actually find that element because the script runs synchronously but just sets up an event listener. So let's verify that that works inside of our browser as well. Great. This is our user agent string, by the way. It's kind of adorable. So maybe we should make it bold. I don't know why, I just suddenly feel like making it bold. So let's put this in an external script. Welcome, we'll call it welcome.js. Here we go. That's nice. And then we'll see if it still works. Yes, it still works. And now it's bold too. Isn't that cool? So if we look at the DOM tree of this document, then what we should see is just a script with its source. No text inside. That's pretty cool. Man. I'm actually quite happy with how this turned out. I think maybe the abstraction is not perfect in the DOM, but it's good enough for our purposes at the moment, so let's be happy with it. We'll add this one. I think we can get rid of that one. Commit A. Alright, so libweb implement script source. Support for blocking, for loading, for synchronous scripts. These scripts loaded in this way will block the parser till they finish executing. This means that DOM when they are encountered, this means that they see the DOM in the potentially incomplete state. It was, I mean, it's not that the DOM is incomplete, it's just that the document is not fully parsed. This is all normal, of course. To make this work, I changed the way we notify DOM nodes about tree insertion. The inserted into callbacks are now incrementally fired or incrementally invoked during parse as each node is appended to its parent. to accommodate inline scripts and inline style sheets, we now also have a children changed callback, which is invoked on any parent when it has children added, removed. Yeah. Okay. I think that's pretty good. That's pretty good. Yeah. So, man, that was a little bit messy, but we did okay. So, should we maybe test this with HTTP? So what if we put a little JavaScript on the Serenity OS website? Let's see if I have a shell here. Yeah. Or no, actually, I don't need to be root. I can just do this in my own web directory. Foo. Okay, so let's see if we can even load that actually. So look at us rendering an Apache directory listing. Sort of. This needs some compatibility work here. But it's cool that we don't crash. So let's see, let's put a script here. We'll do a web page. So head script source script.js. Okay, and maybe a body and maybe a close tag. Hi. And then in script.js we will say something profound like why not hello friends? Tried and true. Alright, look at those extremely awesome hyperlinks. That's a bit of a mess. Hello friends, so it totally works. That's so cool. I was just a bit concerned that it would break when we used HTTP protocol instead of file protocol, but it seems like it's all good. And look, the garbage collector runs when we reload and all kinds of nice stuff. Look at us, building a browser, step by step. It's pretty fun. Okay, great. So we didn't change anything now, so I think we're pretty good here. And I think this is going to be it for today's video. So this one was a little bit of a struggle, a little bit of uncertainties around this, but we ended up with something working, and I think it's pretty okay for now. And we'll keep iterating and keep improving this, but script source is definitely a crucial building block in moving the browser forward. So I'm glad that we now have it. Yeah, so thank you for watching. And I hope you saw something interesting. And I wanted to say I'm really happy that so many people are working on libjs lately. It's really, really fun. And that's really awesome. And I guess it's my hope that people would want to mess around with libweb as well. But I understand that it's definitely, libjs is definitely a lot more approachable because it's like kind of compact and understandable in nature, but libweb is a bit more hazy, but we'll see how it goes. The important thing is that we're all having fun, and I think this is really fun, so thank you for watching, and I'll see you next time. Bye.